Okay, good morning, everybody. Thank you for coming to this, I guess, first in-person session. We had a session at the January virtual meeting about data standards for linking geospatial data with patient records. My name is Ann Thesson. I'm one of the co-chairs of this session. I'm also the only one that's here in person. And my helper over there, what's your name? Lauren, my helper Lauren, will help me make this session run smoothly with all the Zoom and the technical stuff. So we've got quite a few participants on Zoom, which is awesome. We'll go ahead and get started. Please go to Sched, click on the external notes document. Feel free to type down anything that pops into your head as important, but also be sure that you sign in with your name and your institution and some way that we can get in touch with you if we decide to make some sort of an ESIP community around this concept. Oh, wonderful. Thank you, Lauren, for putting that link in the Zoom chat. So I think we'll go ahead and get started. Our first speaker is going to be Kristen Hansen. Oh, here we go. Our first speaker is going to be Kristen Hansen. And I can't get this out of here. Okay. Kristen Hansen, she's going to tell us about linking environmental data with personal level clinical data. And Kristen works at Axel Informatics. And we must give Kristen a round of applause for being here because she is on the West Coast and it is as early as it is for us. It is even earlier for her. So thank you very much, Kristen. Take it away.
No problem. Good morning to you all, and yes, I am used to getting up early. I do have an infant, so it prepared me for this day. You will probably see the sunrise at some point during my presentation, and that will be great for all of us. All right, so I will give a little bit of context that I wasn't necessarily going to, because if Jim was going to kick off the session, but I'm going to talk a little bit about linking environmental data with person-level clinical data and EHR data. I work on the CLAD project for all of us, and I am the environmental data lead. And I have to deal with a lot of the challenges and opportunities with linking these two disparate data types when there aren't sort of existing standards to do so. We are limited in some ways to a case study of using the Environmental Justice Index from the CDC, and I will henceforth refer to it as EJI. What is EJI? The dataset design and purpose is a little bit, it's like an American Community Survey or all of, it's just a way to have a environmental burden, social vulnerability, and health vulnerability linked to census tract and census information. This is to rank cumulative impacts of environmental injustice on health. So it is all in service of creating an index measure, the Environmental Justice Index, which has three focuses, of course, the SDOH variables, the environmental burden variables, and the health burden variables. There are 10 domains, and so these are the domains here on the right, and the variables are collected and stored in this basic CSV with census tract. And what we do know is that all of these have different types of data units. So often they are ranked, and their source data is from all over the place. So the social vulnerability information is almost all from the American Community Survey. Some of this environmental burden is coming from modeled data from the EPA. And then the health vulnerability is coming from the places data set. So the source data is different types of data, but they're all aggregated up to the census tract or downscaled down from county to census tract. So there's a lot of challenges in working with a data set like this, where every single variable has some weird aspects of it. There's a lot of unit concerns. So our categories are a lot of different things. So we have ranks and sums of ranks, and our least favorite thing, ranks of sums of ranks. And we have area weighted population counts, we have population weighted means, we have area weighted means. And because of this, we have a lot of issues with doing any sort of aggregation. So when we are going to include the Environmental Justice Index, for privacy concerns, we are not going to be allowed to include the census tract in the final data set. And we are not even necessarily allowed to include the values, even if the census tract is obfuscated. So because the values across the variables are unique. And so for that reason, we have some concerns, and we have to do a lot of aggregation to aggregate up to a particular spatial layer, which I'll talk about a little bit later. But because of that, we have to deal with all of the different types of variables that we have and how different aggregation will work for these different variables. Our other issues with EJI include that there is no Alaska or Hawaii data, and there are no territory data. So because of this, there are some concerns within CLAD because all of us is focusing on underrepresented populations, including Native American populations, and Alaska and Hawaii and the territories are important for that purpose. So in addition to difficulties with EJI, in privacy, there's also the time variability concern. So the Environmental Justice Index was released in 2022, and it is static. So as of right now, there is only one version of this that was released. It was the 2022 version, but the source data comes from different times. So for instance, the PM 2.5 and the ozone data comes from 2014 to 2016, but the ACS data is coming from 2015 to 2019. And so we have different time scales for the data. And so when we're linking into patient records, we have to be very careful about how we do that linkage, because we don't want to invite bad science by linking in time a piece of information that is not applicable to that time period for that person. And additional privacy concerns is this CLAD is subject to an expert determination, and this environmental data is being linked to not only EHR data, but claims data, and for one tier of access, genomic data additionally. So because of this, it would be relatively easy if you linked all of these things at the census tract to re-identify a person. And really, we're trying to get down to a quote unquote acceptable risk of re-identification. So geospatial data in general is the most highly problematic for re-identification risk, because where someone lives is often public information, especially if they own their house, right? So identifiers and quasi-identifiers are used to give an idea of what the re-identification risk is, what the uniqueness is of a person in a place at a particular time. And as you can imagine, if we have EHR data, if we have claims data, we additionally have survey data in the All of Us platform that has really granular race information, for instance, that you can pretty easily narrow down someone who lives in a census tract. Because EJI is just a snapshot in time, we don't necessarily have to deal with the long time scale of residential histories that would be coming in from our vendor data. Because of that, we don't have to worry so much about knowing where someone is for 40 years of time yet, because we're not linking in a data source that has that 40 years of 40 years of data, but we do have to consider that people are relatively unique even at a single time point in a census tract. And because we're having an expert determination, we are not sort of in charge necessarily of exactly how this obfuscation will work. So it has to be obfuscated in some way. We can't give the census tract data as it is, and it can't sit on the workbench with all the other sources. And so we have to work with a Privacy Hub team to decide exactly how we're going to obfuscate the data, but make it as useful as possible for an end stage researcher. And then in addition to the privacy concerns, I mentioned time variability. So the goal of CLAD for the researchers on the end stage is to be able to do exposure science. But exposure science does require time information. EJI, as I said, is a snapshot in time. And because of the different time periods, we have to be careful about how we link in time. So we are working from the time periods of the variable sources instead of linking them all to 2022 or what is the present day within the EHR data. But we have some concerns with this regardless. So the air quality data is from 2014 to 2016. And what the unit is for this air quality data is the number of days in a year that a particular census tract has a quote unquote higher than parameter value of PM 2.5 or ozone. The reason, and I'm sure this group probably knows this well, but we don't particularly like this this way that this variable is being put about, and that's because PM 2.5 and ozone, of course, have hotspots, and we won't be able to count for that. In addition to it being number of days per year, we also have the problem where this data set is throwing away all extreme events. So in particular for PM 2.5, it is getting rid of all wildfire smoke days in any census tract. And so because of that, it's really flattened. It's really regressed towards the mean of PM 2.5 rather than representing acute exposure. We're just representing sort of lifetime exposure, and only from 2014 to 2016, which are after the time in which these particulates have been reduced quite a bit in the American airspace. And then in addition to air quality and environmental measures, the places index, so the health burden information comes from the 2020 survey after the census. So that is a concern because that module will then be linked to later time periods than we would be comfortable linking the environmental and the social information. So we are considering how to differentially link the different variables in time separately with the different individuals and their residential history. So the goal would be to make this EJI data as useful as possible to do some sort of exposure science. We're not opening the door fully to exposure science because I think that would be inviting some bad science with just this data set. But in order to make it as useful as possible for this research, we have a couple things that we've been working through. So we have to handle the spatial domain of the data because census tract will not be available. So we have to consider what spatial layer, what aggregate measures we are going to use, whether that be to categorize the variables, aggregate them up in space, etc. We need to handle the time dependency issue. So as I noted just now, we would link time differentially based on variability in the data. And then we would wait for the ability to include other data sources that will open up our more opportunities for exposure science. My background is spatial statistics, so I would in remote sensing, so I would really love to be able to include remote sensing data. In addition, the data is available in a passport model structure. So data access is, you get access to everything that's on a particular tier all at once. And so this makes it a little more difficult. We have to consider all of the different tiers separately and how exactly we're going to give the data, but census tract level exposure information would be more ideal here, not because it would be helpful for any sort of spatial modeling, but because it would be the lowest, the highest resolution data that we could get. So the proposed access solutions are there are 3 different tiers. There's the public tier, of course, that would just be making pretty maps and the thing. But registered tier and control tier. Registered tier, there's no spatial information, so we are not allowed to include spatial information, so we don't need to aggregate up in space for EJI. However, we do, because the census tracts are unique when you include all the EJI variables, you have to do a couple things. You have to categorize the EJI indicators or remove some of the indicators from use. We would prefer to categorize up, because there are some researchers that are interested in using, for instance, SDOH data, and they almost always categorize. And if we categorize all the variables to like 10 levels, hopefully not up to quintiles, and then the spatial layer would be included, would be state, but that wouldn't be linked with any sort of aggregated EJI. And then in the control tier is the tier that has the most data. So that has genomic data and all of the survey data from all of us, everything. But we cannot provide the data at the original level at the tracks. They're too unique. So what is sitting in the control tier right now is zip3, which between you all and me, I hate zip3. So we have been working with the privacy team pretty closely to try to find a different way. So the EJI indicators will need to be spatially aggregated, and we are considering spatial aggregation up to, at this point, hexagonal grids. I'll talk a little bit about this in one of the following slides, but because we want to be able to have relatively consistent size of the data or of the spatial domain, some sort of gridding is ideal. And because of the size of the United States and the curvature considerations, we are considering hex layers currently. We just really want to avoid zip3, because zip3s are not contiguous across the states and are not consistent in size. And then additionally, we're considering sequestered data sets where we could give more granular EJI values with only the information from the other data streams that is necessary in order to answer sort of a bucket of research questions, but we haven't gotten full approval to do so. So we're waiting with bated breath for the IRB. So we are considering holding an entire spatial layer index within the linkage platform that we're working in to link this EJI data. The one benefit of being in the environmental data group and leading that group is that we have access to our data already, so we can start playing with what exactly we can do right now, because I can just download the CSV from the CDC webpage.
So Kristen, we're at time. How many more slides did you have?
I have like one.
Oh, okay. All right, go ahead and finish it.
Okay, so I'll be quick. So the idea is we're keeping all of these spatial layers. We've been working for months. My team has been working on getting the different spatial layers together for EJI, aggregated accurately. We're doing a lot of data quality to make sure that the aggregation is happening correctly, because there's all of those different data categories like sums of ranks, which don't aggregate particularly nicely with the normal ways that we would do so. And so this is some of the GIF of the different layers that we have in Ohio, because that's where my team lives, but I live on the West Coast. And then the sequestered data sets, I don't think we really need to go into detail, but after the base period, we are considering ways to do some downscaling so that we can have even smaller spatial designations that aren't necessarily identifiable, but are have high resolution. So that is all. And thank you for your time. And I am delirious and the sun is now rising. So good morning to everyone.
Okay, thank you, Kristen. So I want to do a quick acronym check. Does everybody know what an EHR is? Okay, electronic health record. Does everybody know what All of Us is? It's an NIH project to collect data from people all over the country. You can Google it right now if you want and see what that's all about. And so the CLAD project, CLAD, is a project that is linking. Was that okay?
Yeah, linkage and acquisition of data. So it's like
Bringing in the environmental and the geospatial component to all of the people in All of Us. So what else? Did you catch EJI, the Environmental Justice Index? So CLAD is required to use EJI for like their first project. But as Kristen said, we'd like to get into using other types of environmental data. Particularly satellite data. Yeah.
Curious about X3 and X4. I think I caught the 3-digit zip. Do you know what system? Do you have a more specific idea of what the system of the X3 and X4 units was? Just out of curiosity.
Maybe say
having a hard time hearing.
Oh, sorry. Can you hear me now? Hello?
Yes, a little bit better.
Can you describe the X3 and X4 spatial units more specifically?
Yeah, so we are actually leveraging the H3 grids from Uber. And Hex 3 and Hex 4 are particular layers in they have a whole ton in the H3 system. We use particularly those two because they tend to be sort of just smaller than zip3, so they tend to be around the size of like larger Western counties. And the Hex 3, that was Hex 4, and then the Hex 3 is slightly larger than a zip3 on average. So those are the two layers we've been including, because having talked to the privacy team, they aren't going to be willing to let us use any sort of smaller designation than something that would be about the size of some of the larger counties. And so because of that, those are the two layers we're considering, but they do come from H3 in Uber.
Curiosity, I was just wondering what portion of the All of Us participants consented to the environmental component?
So the All of Us participants are consented, and they because CLAD is more than just environmental, so CLAD is environmental, but it's bringing in the claims data, and it's also bringing in mortality data from vendors. And the participants are consented to have vendor data pulled from them, and that is also the residential history information. In the agreement that the residential history information is not shared with the workbench, we can just use it to link to sort of neighborhood level effects with the Environmental Justice Index. So they all, well, they're piling in. So there's, I would say probably something like 3/4 right now, but they're hoping that we can just have, with every data release that they have in all of us, that we can also link to the environmental data.
Okay, let's go ahead and move on to the next speaker, which will be Andrew. Andrew is at Tufts University. And he's going to tell us about his work with something called Odyssey, which is a health record standards body. There we go. All right, Andrew, take it away.
Hello, everyone. I'm Andrew Williams. Can I get a sense of how many folks are there in person?
So we've got about 10 people here in person in the room.
It's a pleasure to speak with you all virtually as well as those online, and I wish I could be there. It's an exciting event. My first time participating. I am Andrew Williams. I am a psychologist by training. I head the Center for Advanced Healthcare Research Informatics at Tufts, as well as co-direct its informatics core for our Clinical Translational Science Institute. And as Anne mentioned, very deeply involved in this community called Odyssey, which I'm going to go into some depth about. Quite a bit more than a standards organization. And in specific, very relevant to the prior talk, how we're integrating geospatial and person-level health data for best practice analytics to be done at scale in this community and other communities that use the common data model that we build and steward. And so Odyssey, I'm going to spend a lot of time on this common data model that we use is called OMOP. It's an extension to the OMOP common data model that we're going to be spending most time talking about. And all of this work is coming out of a work group within this community, the Odyssey GIS work group. And it is a whole tool chain that allows the standardization of place-related data to be analyzed in combination with this person-level data to produce reliable evidence about health impacts. And it's meant to be very generic. It really can be applied in lots of different places for a lot of different kinds of place-related data. And that's the goal, and the reason it takes a while to build is to make it generic and reusable in that way. The data, as we said, are normalized to this common data model called OMOP. And yeah, we'll go into a little bit of depth on the extensions for place-related data. OMOP is really designed for clinical data originally. And so we're talking about building on top of something that's already a robust ecosystem for doing analytics with this clinical data. That common data model is built and maintained by the Odyssey community, but there's a lot more to it than just the common data model and with its schema and vocabulary. And that's a lot of what I'm going to be covering. So Odyssey stands for Observational Health Data Science and Informatics, and it is a global open science community, and it's devoted rather relentlessly on generating reliable medical evidence using this EHR data, where the targets, the consumers of the evidence that we are producing include clinicians, patients, policymakers. For the most part, it was designed to be used in a federated way. So some of the issues around data sharing, privacy protection, and so on are handled by not centralizing the data to begin with, but by allowing data holders to keep their data, to normalize that data locally without sharing it, and then bring the model to the data and only aggregate the results. I'm going to go into how that works in a little more detail, but that's a key feature of what Odyssey does. Not all OMOP using communities do that, including all of us uses OMOP. The National COVID Cohort Collaborative, National Clinical Cohort Collaborative uses it. eMERGE, devoted to linking genomic and EHR data, all use OMOP. It's used around the world. Very big, so something like 12% of the world's population, we estimate, is a very conservative estimate, has a record in this common data model. And the studies done in the Odyssey community are often the largest of their kind. It doesn't assume that every entity that has an OMOP common data model instance participates in Odyssey studies, but even the subset that do often produce studies with hundreds of millions of records where you really get a sense of how things vary across populations and across geographic regions. And it's been successful, so it's been very widely adopted by major research efforts as well as whole governments. It's used by regulatory agencies to make decisions, both in the US and in Europe, and whole nations have used it to guide how they define care and optimize it and so on. And it's done some interesting things, like through really scrupulous attention to the methodological issues that can make observational research of questionable reliability. It's been able to do a lot that really moves those methods forwards and implement a tooling ecosystem that provides automatic use of best practices that lead to better reliability, and doing so, in some cases, precede the results of directly related clinical trials at a much lower cost. The community, I won't go into this in great depth. Actually, there's a fair number of slides I'm going to go through fairly quickly because I assume the slide deck itself might be available and they'll be there for reference, but it won't be confusing as I go past them. They're just sort of added information. That includes this. I'm going to go through this quickly. The Odyssey website goes through its vision and values. We're devoted to observational research producing a comprehensive understanding of health and disease and the effectiveness of treatments. That's obviously a large ambition, but it's a large-scale effort, as you've seen. And these are the values: innovation, reproducibility, community, collaboration, openness, and beneficence. And we mean all of those. Here's, in general, how the whole thing works in this federated way. So the left-hand side of this figure, the gray box, shows 4 different data holders in this federated structure. So they're not sharing data with each other at all. They're taking whatever source data they have. That ETL arrow means extract, transform, and load whatever kind of source data they have from clinical settings into this common data model, where it sits in a relational structure that I'll describe. And then standard analytics are applied to that standardized data. The community has developed these standards. So over on the right, outside that gray box, you'll see what the Odyssey collaborators are doing. They're developing these standards that are being used very widely. They're also developing tools that assume the data are in those schema and using those standard vocabulary representations. They do a lot of methodological research, comparing various different ways to do everything from prediction to effect estimation and characterization. And those methods are implemented in the tools that are applied to the standardized data. And then finally, on the right-hand side, the lowest, I guess farthest to the right, gold box is clinical evidence generation. So you got policymakers, clinician scientists, other folks coming to and participating in the community to use those methods that applied by those tools to those data. That all gets specified in a protocol. Each of those 4 data holding sites gets that protocol. It's usually a fairly concise package of R and Python code. It's designed to run automatically against the CDM, so it runs locally. And then the results, the standardized summary statistics, are shared and aggregated centrally. There's a lot of methods, research on how to do that aggregation efficiently and effectively to come close to reproducing what you would get from a pooled analysis, closer than a standard meta-analysis, for example. So that's the overall structure of what it is. It looks like to do work in the community. This is a little outdated. It's a map is understating the size of collaborators around the world. Gives you some sense, though, of a little over a year ago what it looked like. And here is this common data model. I'm not going to go into great depth on it. The key pieces are the blue rectangle all the way on the left-hand side. This is where observed data from clinic settings goes, basically. And it's a person-centered model. You get a longitudinal picture of each person's visits and all the conditions and medication orders and procedures, devices that may have been used, lab measurements, and other things that happen at those visits. So that's the way the data is organized. You get people who have visits and sub encounters within visits. And, oh, pardon me. All the rest of that information is linked to the person through their visits, which gives you a sort of a movie, what happened over time to the individual. The key thing that's made all of this work and so successful is this lower rectangle right in the center, which says standardized vocabulary. So there's a really large scale effort to take all the heterogeneous kinds of data and have distinct concepts that have a unique resolvable ID and a good hierarchical order that allows you to roll up within categories or find related things, and annotate that data in a way that makes it interoperable. So the data look radically different from one site to another. My data at Tufts on labs will look radically different than my colleague at Columbia's data. And even though they look radically different to begin with, they all get mapped using these standard vocabularies to a standard concept that any kind of code can assume. So you can assume both what table it lives in and what things mean, and how the relationships, the hierarchical relationships amongst things should be understood. And that provides a lot of different kinds of value for computing and doing research, and enables all kinds of good, robust tooling for investigating and working with the data. And it's the success and comprehensiveness of all of that that's really made this a very large, successful effort. Here's a little bit on the analytics. As I said, there's a really robust community doing both software development and methods research that gets applied to this. This is taken seriously, so it can be used at a production level. It's an open source community, just like it's an open science community. So there's open source repos in GitHub for the Odyssey organization. This snapshot on the left-hand side, which is illegibly small, does tell you the kind of thing that's tracked for each of the major packages that are a part of this software ecosystem. Includes unit test coverage, build status, open issues and pull requests, who's the maintainer, dependencies amongst those things, and so forth. And it just gives an indication of the, a bit. There's over 200 or so repos in there. Only some of those are kind of considered the core things that are often used in doing research. And here's a little bit of a picture of what it's like to do a study using this whole system. Along the top, all of those disks are the distributed research network, but a study kind of goes from the top left to the bottom right, where there are stages where diagnostics are applied and either passed or failed on the way from going from a question to the produced evidence. So there's an evaluation with standardized diagnostics and standardized tools for data quality evaluation, and you might, a given data contributor in this federated network might or might not pass that. If they do, there's a stage where you're developing the computable definitions for who's the population in the study, what are the covariates of interest or the model features of interest, et cetera. That's going to depend on the kind of study being supported. Diagnostics around those sensitivity, specificity, other performance characteristics of those computable definitions will be evaluated, and a given site's performance may or may not pass. And then there are all the analytic assumptions, depending on the kind of study it is. These have their own diagnostics, and they may or may not pass. And only if they all do are they to be unblinded and combined for aggregation and inclusion in the final results. So that gives you a general sense of the kind of some of the workflow of actually using these and how the tools get applied. This is all very generic. I'll say that the kinds of studies that this tooling support fall generally into three broad categories of characterizing care, doing some form of comparative effectiveness research as a variety of cohort methods that are supported, a really large set, and a very large set of prediction models and a framework that's very general for how to apply any kind of classifier or predictor in this in the associated tooling. These are some of the slides I'm going to go through quickly. This just shows some of the tooling. It's the same slide with pictures below of the kinds of tooling that have been developed by the community to do some of these diagnostic checks. So this one is for data quality. The next one is for the cohort diagnostics, and the last one is for some of the analytic assumptions. Beyond all of that, there's an even broader ecosystem to create and maintain a thriving community of users of all of this. It includes education. So there's a living document, a book called the Book of Odyssey, which goes into all aspects of this in depth and is updated. There's hundreds of hours of YouTube tutorials on how to do things. An open courseware system has been completed by hundreds of people. Engagement efforts include regular community calls attended by over 100 people every Tuesday, vibrant public discussions on the forums in various different categories, regular symposia in different continents, asset libraries of validated phenotypes and prediction models that can be downloaded and reused, and all the results are shared in public. I see that I was being highlighted there. I got a message that the host had highlighted my video. I'm sorry if that was disruptive. The way in which patient level prediction or any kind of prediction task is handled through a set of tools has some corollary to what we're doing by extending the common data model and the analytics ecosystem I've just described. So I'm not going to go into too much depth, but it has, actually, these are just the principles used in the Hades, so Odyssey. The pronunciation of HDSI is Odyssey. And unfortunately, we kind of saddled ourselves with having everything have some sort of reference to the Greek epic narrative, the Odyssey. So all the different acronyms within the community have this Greek reference, including the overarching set of principles and support for open source methods and tooling development, which goes by Hades. So those are some of the principles applied in Hades.
Andrew, we're at time.
Oh no, you can't be serious. Can I go 1 minute over?
Sure.
I can't believe we're at time. Let's see the extensions. So this is, I think, serving clad as well, right? Or Jimmy's going to talk, I guess, whether or not it is. But we've extended the vocabulary in 3 ways to have specific vocabulary for geospatial elements, for toxicants, for social determinants of health, including the social justice index. We've extended the Odyssey OMOP schema to include an exposure table and location history. And my gosh, I can't believe. So I had all of these will be there for your perusal later. If I'm going to stay to a minute, I can't really go too much into depth on how these all work together, but here's some useful links at the end. It's an open science community. Everybody is free to just come and check it out. You can go to the links for it and join. You can lead a use case that leverages what we've built and or add to it in ways we're really mostly done with a lot of the basics for the schema and the vocabulary and making sure the rest of the ecosystem can work with it. We need to expand what we do with visualizing data and geospatial analytics that are different than regular analytics. So I think people in particular who have use cases to actually generate evidence or want to contribute to that are really invited to come see what we're up to and contribute. It's guaranteed to have a large impact. We're supporting this in various pooled resources, including in the future, the National Clinical Cohort Collaborative, Bridge to AI effort. It's going to be applied in lots of different places around the world. So you'd have a amplifying effect of your contributions if you did. So thanks very much for your attention, and sorry for misjudging the time I had.
Okay, that's okay, Andrew. If you just send me your slides or send me a link to your slides, I can put them in the folder for this meeting. Does anybody have any clarifying questions for Andrew? I don't know if anything's happening on Zoom. Okay, I'm getting a thumbs up. All right, so our next speaker is Jim Bung. He's at the University of Washington in Seattle. And so you heard Kristen talk about the type of environmental data that we have to work with right now. And Andrew just talked about the patient data that we're working with right now. And Jim's gonna get down into the meat and potatoes of how we're gonna bring those two things together. And I would love to get your perspective, your comments on the actual data structure that he's gonna be showing us today. So with that, go ahead and take it away.
All right. Thanks, Anne. And thanks, Andrew. If you were to, I think there's some segments of my slide deck that can jump back over to Odyssey. So, but I think I am going to go a bit more into the meat and potatoes about like data structure, document, and the schema of things. Let me know if you can see my screen. Yeah? Okay, thank you. All right, so I'm gonna try to stick to just 15 minutes with this, if not sooner than that. And then we can always come back and just have some discussion. I'm gonna talk about not just the process of geocoding, but multiple geocoders and how we've been sort of going about it for metadata standards, given that there's not a clear single set of standards. This is working. Okay, there you go. So the objective of this talk is to consider how to enable clinical data enhancement through linkage with spatial temporal information, explore operations of using multiple geocoders, and then to assess quality of geospatial temporal linkages. On the right side here, this is just a diagram to consider how in some past publications, how have we gone about discussing specificity of social terms of health information. This is either at the individual level gotten from a person, geospatial inference through like census block or where people live, or to some degree of like a county public health report. But there are different types of data sets out there, and Kristen will cover environmental justice index and spatial information of that sort, and it'll also be covered in one of the slides in this slide deck. But just putting this image out there to consider that there are different types of data and there are different scales of it to consider. About a year ago, Anne and I and Kristen, we had gotten started with a project called National Institute for Health, All of Us Research Program, Center for Linkage and Acquisition of Data, CLAD. And with CLAD, we were charged to do multiple forms of data linkage. And the project, the segment that me, Anne, and Kristen were working on, we were essentially doing these 5 components: address discovery, geocoding, quality assessment, the representation and scaling with different orders of like census data, because at the time we were mostly thinking of these census-based data sets, the integration of them. But once we were integrating them, we were considering that like there are multiple scales of data. There are some data types that are generated and initiate in some gridded systems. And then once we've done these linkages, once we've got these associations to link everything together, how do we go about putting them together? And augmenting or enhancing data sets means that we would also have to consider, is this going to change the potential for re-identification, this specificity of certain vector of information, and how that changes, spatial statistics or spatial risk or re-identification risk. I'm the milestone lead for geocoding, so I've mostly been thinking about how do you get from 1 to 2, 2 to 3, 3 to 4, 4 to 5. And initially I had this diagram out because address standardization, so this is that address format correction, range conformance check, geocoding. The operation was a little bit of this iterative loop, but address standardization was part of this and initiated through this into geocoding. And that eventually led us to ask, how does data get stored? And if we're gathering this data from a research program where they're self-managing it, or if we're gathering this data from like a hospital system where it can be coming from multiple hospital records that then get reconciled, or if we're getting it from a separate vendor and they're able to tell us what else did they do to prepare and standardize the data, how do we then consider each record? What does a record mean for a person's place and time, residence and time? And then if we were doing these environmental linkages, are there certain interpretations that we should be cautious about? Because well, environmental linkage might mean you need to consider where a person was and whether that data is applicable to address history or residential history that reaches back 50 years versus 20 years or 5 years, or, how does it overlap? How does a residential history overlap with the logic for the data set itself? So that then brought us over to this question about the metadata. What do we need to store in order to make some of this logic? And how do we store it? When we're going through the landscape of ISO standards and reporting standards and address standardization standards, some of it is very much national standards. Which one do we adhere to? How flexible is the standard? And what is some decisions that we should have in place, even to choose between standards? So, not just simply doing this now, but like, what do we want to enable in like future linkages or future use of the data? So I'm just going to leave this as like the thought-provoking question slide. So while we think about workflow, we also need to think about like what type of data, metadata we're utilizing. We had an updated geocoding operations in January. So the last time I had presented this slide deck, this was actually the set of operations where we're no longer going to do the address standardization from the get-go. We're going to take the addresses and consider whether we can process them into the components for the input into the geocoders. And we're also not just using one geocoder. We're going to use potentially 2, 3, 4. There's different types of geocoders. So like, do we want to weigh the benefits of using one type versus multiple types? And we around January time, this is also when we got more deeply, actually, no, it's last August. I got more deeply in touch with Andrew and the Odyssey GIS working group to consider how they've automated their process from 1 through 5. So I hope Andrew was able to discuss Gaia Core and some of those components from the Odyssey GIS that essentially has a geocoder built in, brings in address information to do the geocoding, and then links that information with the environmental data sets that they've established controlled vocabulary for. That part is downstream and would be like the step. You could either do it simultaneously, the way that we've talked about it is like from the address standardization side, or from the environmental data preparation side. So what I'm showing you here is actually from the address to geocoding first. I do want to acknowledge number 3, 4, and 5, which is just more of the address geocoding quality, digging more deeply into how does each geocoder operate through their geocoding processes. What do they report back for quality? How do we determine if the address was geocoded to an adequate quality or if it was basically not found? And across the different types of geocoders, interpolated based and parcel based, there are different associated quality metrics that come with them. And how do we gather all of that together, and then how do we reconcile it? To define number 5, which is the best geocoder, and then that's the one that we would use for the linkage with environmental data. I also want to put this forth. This is also another linkage with Odyssey GIS working group, in that the research consortia we were working with, all of us research program, they have previously prepared their data using an OMOP common data model instance. So they have their data represented in a series of tables as seen with the standardized clinical data schema. But what's not shown as part of this is all the other work for extending what's in that standardized health system data from location and location history to where the geocoding processing happens, all the quality metrics, and all the environmental data linkages enabled downstream. But I also want to just place focus that the reason that one might consider extending and inferring environmental data linkage is so that we could consider this in causal studies, correlational studies, ecological, consider things that might be ecological risk factors, but while doing so, also weigh that with, is there a potential ecological fallacy here from use, treatment, or interpretation of a single variable? But it's a space-time effort. So like where a person lives and what type of data that we're linking with them. There is the potential that if the temporal aspect is not maintained, we could have a problem downstream of environmental information, but it's actually like future information. So you have like a information leakage problem. And separately, like how to enable and what to do for clustering and spatial effects. This is the first portion of it for the address processing and then the OMOP data linkage. We start off on the left side where we're processing the address information either as just a series of unique addresses that we're going to geocode. And if there's a temporal component to it, then we will separate those as like location and location history. On the bottom, you can see like if we are getting the data from another source where they might have a larger pool of patients, how do we subset that down to just the segment of the patients that we're going to transform and represent as location history and location history? If there are any matching algorithms or temporality is being matched into, this is the same person, this is a period of time they lived at some place, and then there's another address, but we don't have a confirmed end date for some things. There might be like a window of time, but there's no clear end date. Then some things like that, like this is where I've gone to Andrew to really consider how do we document matching algorithm or the application of address correction or address standardization, or if somebody had actually gone through and done manual validation of the records, how can that and how should that be documented? And initially, we were looking towards the fact relationship table as a way to just store these as a simple set of like triples. I know Andrew has some thoughts on this, but currently that is still like the best thing that we could do. But on top of preparing the data as location and location history, then we would document, we could just add additional columns in those tables to document those effects, or we could store those into a separate series of tables so that the relationships are we can keep the location and location history as canonical as possible, and then use the fact relationship and overload for some of these other information to enable linking it back. While we're doing this, the controlled vocabulary, it does come up. We do have to consider, are we dealing with some data that is from the source? So it's from the vendor that attests that they had done address standardization, or are we doing it downstream and thereby we're going to document that afterwards too? So where does this come from? Now in this figure, this is actually one large flow diagram, and I sort of cut the left piece, talked about this with regards to like the more OMOPified components as we get ready for the rest of the linkages. Oh, I forgot to point out the stuff up top. So those are the other OMOP tables, the person table, provider, care site, visit occurrence, and death. So these are tables in which like we might want to consider how does that link back with like where a person was, the location history. But to the next step to the right side of the flow sheet or flow diagram was the multiple geocoding component. So this is where once we've got the addresses prepared, address 1 and 2. Oh, did somebody just message something in the chat? Oh, 2-minute warning. Okay, I will wrap this up. So the address input, basically across all geocoders, we've got 3 geocoders here: the UW PostGIS geocoder, the Gauss geocoder, and Nominitim geocoder. In preparation for these, we treated each of them as Docker so that we could do reproducible installations. And if we needed to make any updates on them, we're able to complete this while maintaining development, staging, and production environments, applying the same Docker deployment. We do have to consider that each of the outputs are different. They have some geocoders might generate multiple outputs, multiple best match addresses or latitude longitudes. We've noticed this within the Gauss geocoder and the Nominitim geocoder. And then once we get into the precision match and the string match, there are sometimes different scores, and those things have to be documented first, and then we could reconcile them for how do we want to interpret within that one geocoder versus across the geocoders. Finally, there's the right side over here where as part of our plan here, we are going to do something that's our iterative, but we do need to review them in an entirety. So is this an issue about the address? And even after we've applied a correction, is this going to save it? Versus is the address itself prone to inaccurate geocoding outputs? And we can understand this about the address, and we can also understand this about the geocoder. So is the geocoder prone to imprecise geocode outputs, or does it tend to have a lot of mismatches? Even so, it has like a false positive rate. It'll produce a geocode, but then it's wildly off base. And then finally, like which one is actually the best geocode? This is like second to last one, I promise you. With environmental data linkage, we do have to consider downstream of this further. So once we have the best geocode, how do we need to establish this linkage? We like refer back to that location history, taking into account both the space and time, so that if we were to do this linkage with environmental justice index, we have these decision steps where if environmental justice index at the variable level, we can't apply it 20 years back. How do we then apply the logic to link that variable, and when is it applicable? Where do we have no data for this type of linkage? For example, EJI has a certain type of extent. It is census tract based, but its extent is only the United States. It doesn't include Alaska. So apart from that, we we might have to take that as a data set by data set basis. We might also have to consider things like the secondary transformations. What is the actual output gridding that we would want this data set to be in? Do we start with census tract? EJI, as it is right now, is based off of census 2010, but in its envisioned future, do we want to have this within a gridded schema, or do we want to have this in census 2020 census tract? And then finally, with EJI itself, I can tell you that within Odyssey GIS working group, the controlled vocabulary for each of the variables for EJI was established as some prototypes number of concepts last week, I think, a week and a half ago. So it's fairly new and it's still in the process of internal review. But even after we've done that, we do need to consider are there certain privacy risks for like the variable being like more sensitive? Are there functional things that we could apply to reduce the re-identification risk within the data set, such as spatial aggregation and data redaction? I've dealt with a similar problem like this before, where like in other programs, some people are trying to deal with data that are gridded. There's multiple types of data, and sometimes it's generated by different algorithms. Gathering all that data, it can be a huge headache, and sometimes people are using like different types of software in order to just manage each of these operations and perform them. Odyssey GIS working group and the Gaia Core software. I think the beauty of that is that it's like a one-stop shop software that is automating as much of this as possible into an open source software. And across that, I would, love to improve Odyssey and OMOP while thinking more thoroughly about like how do we do this with an ensemble of different geocoders. I know I'm over time, but I think this is my last slide, which is sort of final call to action and discussion. So please reach out to me if you have any thoughts and thoughts for discussion. But we have a project right now which is preparing for research with a data set downstream where it has been enhanced with EJI data. But we do have to consider like what scale are we thinking about? How do we include or consider geocoders that interpolate based off the road network or parcel land layer? And if we added additional geocoders or additional address standardizations downstream or later on, how do we do that while protecting patient privacy and not having potential breaches with such processing of such sensitive data? Here are the two citations that I've referred to in the paper, and then I'd like to thank the All of Us Research Program Center for Linkage and Acquisition of Data and Odyssey GIS Working Group for being fantastic contributors and collaborators. That's all. Thank you, and I'm sorry for going over time.
Great, thanks, Jim. That's perfectly all right. So I want to remind everyone that, I know some of those diagrams may have been really hard to see up on the screen, but if you go into Sketch and click through on to the Google Doc that is specific for this session, all of the slide decks have now been linked in there. So you can go on your own laptop and look at them right now if you want to kind of stare at it and think about it for a little bit. But while you do that, does anyone have any questions for Jim? I think we did have some questions in the chat, didn't we? Okay.
I saw one post from Huang. So 2 questions. Have you automated the geocoding procedure and the linking of health data from multiple sources? Sort of. So the linking portion is Odyssey GIS working group has created the Gaia Core that software, and there's like some schemas displayed to represent how do they go from addresses, conforming them over to the location and location history tables, and then processing them through, I think Gaia Core is just processing it through one geocoder, so Gaia the Gauss. And then the downstream outputs from the Gauss, they make a educated best geocode decision, and then they basically get from here through here through here, and with the best geocode, then they do this linkage with the I believe they've done this with social vulnerability index and are in the process of doing that with environmental justice index as well. But for multiple geocoders, my bottleneck right now is actually reconciling all 3 of the outputs from my deployment of 3 different geocoders. I know some sites might have more, but like they might have to make a best guess, like which one is actually the closest to ground truth. I might say the parcel-based geocoding is the hardest to understand because sometimes in a single address, you can have multiple parcels overlaid on there, and they might be on there for different reasons. But if you had interpolated based matches, sometimes the address is like a 100% match, and that's great. Then that's something that you can establish as like that's the best geocode coming out from this one. How does that compare with DeGauss, where their string match and their rating might be a slightly different? But reconciling it across the different methods, that's the current difficulty. So the second question is, what is the output of the geocoding process? Is it point data, or was it merged with block group? How could you protect the patient's privacy if it is at a very granular geographic unit? So thank you for that question. Currently, out of each of these outputs, the sometimes it is each of them are establishing latitude, longitude, and what we're going to need for those latitude, longitudes first to consider what's the error rate and the accuracy output from each of the geocoders, and from is this established. Each of these are being attributes generated from the same address. So does this one address end up with wildly imprecise or wildly different outputs? So we do need to have these at this stage captured at the latitude longitude level, but eventually this latitude longitude it would need to be linked to a primary attribute level. So in this one, we were talking about census block, or potentially census block group, or census tract. In some research, we can envision doing neighborhood level research. But within the All of Us research program and Center for Linkage and Acquisition of Data, currently we've been discussing these development of downstream data sets, and we simply don't have a good use case for census block that is sensible to the risk of protecting, the risk of re-identification. Census block is too specific, and the specificity of it for neighborhood level research is prone to a lot of misinterpretations because of what census might have or what a certain data set might have, especially if we've got like location history, like a person's moving over time. So if we're establishing this person as at different places over time, is a census block highly and overly specific? Is a census tract already at that degree of potential re-identification because of how specific a place might be relative to other places? So at best right now, we can get down to census tract. If we go up to county, then there's a potential that this is just information loss. Like it's aggregated too far up, and the effects at a local area, local enough for effects, high, but not too low or too specific of a scale in which you're dealing with like 100 people in that area. Census block can get highly specific. It could be like, less than 10, or in multiple data sets from census, they have chosen to redact any data counts that are below a certain level. So I don't envision any future where we're using census blocks as that measure for the finest level, or for the data release. What we might do is, after we've established the latitude, longitude, the best geocode latitude, longitude, then we immediately, this is all within like a protected environment, and after it's done, like we just archive it. But from henceforth, like any other linkages we might be wanting to establish, we might just keep it at a census block level and then link everything that is gridded or census tract, or with gridded, there's like different types of gridding. So if it gets too fine, or if it gets to a certain degree where we have to do pre-processing to link the spatial layers, that's definitely something that we want to consider as a potential, like this is the layer required in order to get all the data into harmonization or conformance. Does that help answer the question? I don't know if you're able to like unmute and continue the discussion, or if you have a follow-up question, but thank you for your questions, Wang.
Thank you for your answers. Those are very helpful.
So,
And actually,
oops,
uh,
go ahead.
Sorry, I have another question actually.
Oh, okay.
So those are very helpful. And one last question is, does this process could be that this procedure could be processed in local network that doesn't need to connect to online? Because I do have patient level data that I needed to geocode, but the IRB process is super complicated, and we need to consider to protect patients' privacy, and at the same time get the we don't want to lose the information, like you said.
Yeah. So I operate in this. I'm one of my functions is as a research data engineer, research data scientist for a health system. So pulling the data from the electronic health records and either getting it into a data set format and conformance thereof, or getting it prepared for doing this type of geocoding in the geocoding environment. I do often have to think about that as like I'm never able to. I think some people take Google as a luxury, or like it's just addresses. It's okay. You can just put this out in there in the open web. But I I I have never actually done that. There's a potential for the address and the IP, the searches to all get logged. So there is a potential for breach in that way. So I always operate in enclave environments. In my site, we have established each of our Dockers as our localized deployments. So you have to be within our firewall and be able to connect with the virtual machine Dockers in order to send the geocode to them and then get the outputs from them. But I know some sites, they have used one of my collaborators, Jacqueline, she uses ArcGIS, so Esri ArcGIS, StreetMap Premium as the software of choice. We were not able to get that into this environment. We're working within like that Center for Linkage and Acquisition of Data, which in their protected environment is there were some established concerns that like this environment, operating system and software ecosystem, installing Esri ArcGIS might be a little difficult. But if you're operating at your own health system, then I would ask if there's a way to create a enclave virtual machine that's HIPAA compliant, HIPAA aligned, and then within that system, install a geocoding software that you could then use. If you're able to get multiple geocoders installed, great. These ones are all three of these are open source geocoders, and they can operate offline within like these closed environments, meaning they're not contacting the open world. They're just doing the processing, like you're dealing with like a on-site computer, something like that. It's only accessible within the network. And
Okay.
then yeah, so that's definitely one thing that I have been thinking about, because some papers, some research, they're just doing one geocoder, or they're just doing one of the methods, like it's parcel based. As Esri ArcGIS is going to run parcel based geocoding first, and if they can't find it, then they'll do a kind of interpolated geocoding. But they're not the only software out there, and there's an ensemble of different methods, some of which operate, at different capacity, different resolution. Just doing a test set, I could tell you that with just on my local deployment, I'm running all three of these, and to run 500 addresses takes like 15 minutes. It's like 2 seconds per address to go through all three of them. So I'm done in 15 minutes.
So I do want to do a time check. We've only got about 10 minutes left. And Jim, I know you had some specific questions wanting feedback on some of these proposed models. So maybe you should dive into that. And if you want to highlight a specific area on one of those diagrams, I would recommend that you zoom in so people can see.
Oh, yeah, sorry. Okay. So I wanted to call attention to this slide, which is these three sort of thinking thought discussion questions. And I think whoever just asked the question about like running well, getting through IRB and running geocoding within your health system. Thank you for the question. I might extend that further and ask like, are you getting what you need to get out of that one geocoder? Or are you not able to establish what is the quality of the geocode down, out that's derived from that process of transformation? So which one do we need to adhere to? I have these example three to sort of start the discussion. We've got the FGDC geospatial data reporting, which is more of a thing for government institutions to do report back to Congress. There's different types of ISO metadata standards, both for time and for gridded data or for spatial, I guess, or for the resolution. A lot of different ISO in order to like, decide on those. We couldn't figure out 1 or 15 of the ISOs are relevant for the research, and we do have to like keep it flexible and adhere to all of them or something like that. But we also established that publication 28 is like the USPS standard for address formatting. And some legacy addresses that might be from health system records, they might not be standardized to USPS. And if we needed to standardize it to USPS, are there some good methods in order to do that? Or do we always have to use some type of third-party software? And they act as a third-party API conduit to ping the USPS servers. That's the route that we've looked into in the last 6 months. And that's also the route that my funders and the All of Us research program, they just have established some concerns about that type of external API call with the addresses, in that it's getting at the addresses are leaving the system, but it's leaving the enclave system. So has anybody who is on the line used Esri ArcGIS, and address standardization is already done in it?
Hi, it's me again. I am Qian Huang. I'm a research assistant professor at East Tennessee State University, Center for Rural Health Research. And I use Esri ArcGIS, actually. So what I do, the geocoding, I use building the street geocoder. And that one is pretty fast as well. I sometimes geocode over 10,000 points, and it's totally fine. Will be a very short period of time to do that. And for the IRB question, so we have connections with Ballot Health, the biggest system in the health system in the Northeast Tennessee and the Southwest Virginia, those type of like some counties to have that. And we requested that data, patient level data, a year ago. And they are still processing the IRB because we are requesting the patient level data. And yes, so it's a very long time, and we needed to figure out how to get the patient level data, street level data, and geocode on the map and merge with other layers like census tract or census block or block groups, depending on how many patients are in that neighborhood. We cannot do less than 10 or 11 in one blocks. So that is very challenging, and IRB is super strict. We only have 2 people that will have access to the data, and I will be the only one who can geocode, use that, and it has to be in local and cannot share with anyone, and the data need to be deleted in 24 hours. So it's super strict. Yes, so we will, that's, I don't want to like waste everybody. I know the time is close. I'm happy to discuss more with you. Yeah.
So my email is at the very top of the slide deck. Please feel free to reach out. I would love to continue this conversation.
Sounds great. Thank you.
In response to yours, my initial geocoding operation, usually right around this depth level, this is where like HIPAA establishes you can't have any like smaller than county identifiers. So zip code and census tract both are potential re-identification risks and are considered sub-county. So if you're dealing with block group or block or latitude longitude, yeah, there's always those clauses where you have a deletion clause for proper risk mitigation so that there's no breach or specificity of the information kept somewhere. So for some of the data types, some of the data sets I work with, keeping it down at latitude longitude is just too specific. And when we're doing analyses, we might want to look at a whole landscape layer, and maybe census tract is as you know, as good as it gets, and we can keep it there. But census block or subtract, I think the main concern with anything smaller than tract is that the population is too small. And if the landscape layer, like rural areas, the census tracts can be quite large, then there might be some potential differences in like the population versus the place are two different layers. You might use the tract as a way to just aggregate space. But if your research is about the place, then I think sometimes that might be considered non-human subjects research. If your research is intended to like return data back or maintain linkage about where people are at the highest specificity, then that's human subjects. So there is a bit of a boundary between like the interpretation of that objective, the research question objective. Okay, so that's my final response. I know I'm way over time, but
Yeah, so we are out of time. I want to encourage everyone to please add their names and their contact information to the Google Doc for this session. If you had any questions that we couldn't get to, please add those in there and I'll prompt our speakers to go look in there. Are we keeping all the Zoom chat? Yeah, because I haven't, especially if there's questions in there that we haven't been able to get to. And I don't know, are we allowed to go into break a little bit if people want to talk? Or is does anybody have any other final questions or comments or anything of that nature? Okay, yeah.
So I was just thinking, hi, thank you all for your talks. This is perhaps taking a step back, but something I've been thinking about with some of my work as well is how you start to approach issues in bias in clinical data, and that like, especially in the US, you know, we're gonna have differences in access. So particularly with that level, we're gonna represent people who might have better access to healthcare resources or health insurance more than others. They just don't know what you guys are thinking in terms of approaching that and handling that. Thank you.
Thanks for the question. Andrew, do you want to take a stab at it first?
Yeah, I think that's solidly within the range of kinds of questions that the infrastructures that you've been seeing are designed to address. Once you've got the ability to measure issues around access that have to do with geography, in addition to, you know, financial or other things that affect access, you're really able to inform policies around those where you understand where, you know, how that's playing out when you're able to see how it, people with different levels of access, geographic or economic, have different outcomes for equivalent kinds of things, et cetera. I think it's exactly the kind of question that motivated all the development of this whole infrastructure. In terms of the particular ways of going about it, there's a lot. There are, for example, at Tufts, issues around what insurance policies cover and why, that are sometimes region specific, where you get your insurance, where you physically live affects what kind of insurance coverage you get. Sometimes that's at a state level, sometimes it's at an employer level. but for an equivalent condition, different policies will cover different kinds of medications or the costs of those. And so you can define populations using this sort of infrastructure and then see what the effects of both economic and physical distance are on the outcomes associated with those policy, those coverage decisions in insurance policies. There's lots of things. Underserved populations who tend to cluster geographically also can be defined, and outcomes associated with that more precisely calibrated than you can when you don't have the patient level data. So those are some initial thoughts, but it's exciting. Hope you start to make use of this sort of infrastructure to pursue those questions. They're very much at the heart of why we do what we do.
Okay, thank you. A big thank you to all of our speakers, especially Jim and Kristen, who are on the West Coast and had to get up really early to do this. We do need to end. The next session is going to want to start setting up here pretty soon. Thank you all so much. Please feel free to stay in touch via the collaboration document. I hope everybody got what they wanted to get out of coming here today. So thank you.